In the beginning, the void did not announce itself with anything dramatic. It appeared first as a whisper in the data, a subtle dimming where there should have been a crowded field of galaxies. At first glance, it looked like nothing more than a missing smear of light on a cosmic map, an ordinary error in an ocean of more urgent mysteries. Yet the longer astronomers stared, the stranger it became. The universe, for all its wildness, follows patterns. Gravitational tendencies, clustering of matter, the familiar filaments of the cosmic web stretching like veins across an unimaginable distance. But this region did not obey any of those rules. It sat there like a silent tear in the fabric of reality, a place where light seemed to drown rather than travel, a wound carved into space itself. Imagine drifting outward from our galaxy, past the bright sprawl of the local group, past the shimmering chains of distant clusters, watching the cosmic architecture unfold as if the universe were revealing its blueprints. Everywhere you look, stars form constellations of order, galaxies gather into superclusters, and dark matter pulls everything into a vast, balanced web. And then, abruptly, that rhythm collapses. The map drops into blackness. Not darkness filled with potential, but darkness filled with nothing. A territory so empty, so profoundly absent, that it resembles a hollowed-out region where the universe simply chose not to paint. The first scientists to study it described a feeling they couldn't quite name, a sense that the void was not merely empty but wrong. As their instruments confirmed the size, the scale, and the impossible boundaries, that feeling deepened into a quiet dread. A 300-million light-year expanse with no significant galaxies, no clusters, no visible scaffolding of dark matter. Nothing. In cosmic terms, emptiness of this magnitude is unnatural, like a missing note in a symphony written by the laws of physics. The universe rarely creates perfect absence. Chaos, turbulence, collapse, birth, these are natural. But a space so vast, so cleanly carved, defied everything their equations predicted. The deeper the analysis went, the clearer it became that this was not simply a statistical anomaly. It was a void on a scale that should not exist in a universe this old, this structured, this gravitationally interconnected. Even the largest known voids, scattered like air pockets in bread dough, do not stretch this far or cut so sharply into the cosmic web. This one looked different. Its edges seemed too crisp, its shape too defined, as though some immense unseen force had pushed matter outward, leaving a great cavity behind. Scientists tried to dismiss that idea. Forces of that magnitude border on the unthinkable, but the void continued to provoke questions that bordered on the unsettling. As telescopes probed its perimeter, the surrounding galaxies seemed subtly distorted, pulled into strange arcs and elongated shapes. It was as if the void exerted a quiet pressure on everything near it, bending cosmic structures with gentle but persistent influence. This was unusual. Voids typically allow matter to drift away naturally as denser regions dominate gravitational attraction. But here, the opposite appeared to be happening. The void seemed to be imposing its presence, not through mass, but through some other, unclassified effect. Every measurement felt like an echo of something lurking behind the data, something that could not be easily named. In the control rooms where astronomers gathered, the void became an unspoken challenge. Charts were updated, simulations revised, hypotheses proposed with confidence but spoken with uncertainty. The atmosphere was thick with scientific curiosity, but beneath the formulas and calculations, a different emotion coiled quietly: fear. Not fear of danger but fear of meaning. If the universe held a feature this enormous that did not fit any known model, what else might exist beyond the threshold of our understanding? What if this void was not an exception but a clue? As the story of the void spread beyond academic circles, new eyes turned toward the mystery. Cosmologists, theorists, and philosophers all found themselves drawn to the idea that something vast and invisible had rewritten a portion of the universe. Was it a relic from the earliest moments after the Big Bang, an imprint of quantum fluctuations enlarged to monstrous scale? Was it the result of dark energy behaving differently in certain regions, stretching spacetime itself until matter thinned to nothing? Or was it something stranger, something that did not fit into the vocabulary of contemporary physics at all? The more the void was studied, the more it seemed to reject every explanation offered. Its boundaries were too smooth, its interior too quiet, its gravitational signature too ambiguous. If it were simply a region of low density, there should be residual traces of gas, dust, or dark matter. But the void behaved like a perfect absence, an emptiness that felt almost intentional. That idea was uncomfortable, so it was rarely stated out loud. Yet even the scientists who avoided such speculation found themselves staring at the data with a lingering suspicion that the void was not simply where matter was missing, it was where something had happened. In a universe governed by physical laws, unexpected patterns are messages. And the void, in all its scale and silence, felt like a message written in negative space. A message that humanity was not yet prepared to interpret. As research deepened, the void no longer felt like a curiosity. It felt like a question so large, so heavy, that it bent the thoughts of everyone who studied it. A question no one yet knew how to answer, but that demanded attention all the same. A question that hinted, quietly but unmistakably, that the universe might be far more complex, far more dangerous, and far more mysterious than any of us imagined. Space as we know it is not supposed to be empty. It is not a smooth, featureless canvas stretched endlessly in all directions. Instead, the universe is expected to resemble a colossal web, intricate, interconnected, and alive with structure. Wherever astronomers point their instruments, they anticipate a familiar tapestry, clusters of galaxies clinging together like glowing islands, rivers of stars flowing along invisible highways of dark matter, and immense walls of cosmic material stretching across millions of light years. This is the universe we have come to understand, a universe that should be full, busy, and architecturally consistent. Yet when confronted with the 300 million light-year void, that expectation shatters, leaving behind a sense of unease that is difficult to ignore. To grasp the horror of this emptiness, you must first understand the beauty of what should be there. Imagine drifting through a typical region of the cosmos far beyond the Milky Way. Even in the darkest reaches, galaxies swirl like embers of distant fires, each one home to billions of stars. Some galaxies burst with new life, their nebulae glowing in vibrant blues and pinks. Others are ancient, dim, and ghostly, slowly fading as their stars burn out one by one. Between these galaxies, gravity and dark matter weave a delicate network, guiding material into vast filaments that structure the entire universe. It's a grand, cosmic architecture, mathematically elegant and astonishingly complex. The cosmic web is not just a poetic metaphor, it is the backbone of the universe. Scientists can map it, predict it, and simulate it with startling accuracy. Wherever dark matter collects, galaxies follow. Wherever gravity intensifies, structures form. There are voids, of course, pockets of relative emptiness, but they are usually small, scattered, and surrounded by dense walls of galaxies. They fit neatly into our models, like missing pieces intentionally carved to balance the cosmic design. The universe needs voids. But it also needs limits. And this is where the nightmare begins. The moment astronomers noticed the abnormality, something felt wrong. This was not a void, they had seen voids before. This was an absence so vast, so extreme, that it seemed to mock the universe's own rules. Stretching nearly 300 million light-years across, it was not a gap, it was a rupture. The kind of wound you would expect only if something enormous had gouged out a portion of the cosmic web, leaving nothing behind. No galaxies. No clusters. No bright spirals twisting like cosmic hurricanes. Not even the faint whisper of dwarf galaxies, the smallest and most common building blocks of the universe. It was as if the universe had taken a breath, and forgot to exhale. To make sense of this, scientists revisited their understanding of cosmic formation. In every simulation ever run, matter naturally clumps together as the universe expands, forming a web-like pattern over billions of years. Gravity acts as a sculptor, pulling material into nodes and strands. Even in the emptiest regions, the pull of nearby galaxies usually seeds the formation of small structures. It is extraordinarily difficult, almost impossible, for a region to remain completely empty over such enormous distances. Random chance cannot account for it. Natural variation cannot explain it. The numbers simply do not add up. This is where the contrast becomes almost unbearable. Space should be full, vibrant, and predictable, yet here lies a region where all expectations collapse. It is like discovering a desert the size of a continent in the middle of a rainforest, a barren wasteland that should not exist under any natural process. And with this realization comes a creeping dread, because scientists know that if one piece of the universe defies prediction, then everything must be questioned. What if the cosmic web is not as stable as we believed? What if the universe has scars? What if some of them are still forming? To confront the void is to confront the fragility of our models. It forces cosmologists to retrace their steps in the dark, searching for the moment the universe stopped behaving the way their equations insisted it should. Perhaps dark matter behaves differently here. Perhaps unknown forces are suppressing the formation of galaxies. Or perhaps, And this is the most unsettling thought: something removed the matter that was supposed to be there. As telescopes scanned the region, the emotional weight grew heavier. Imagine looking into a place where nature seems absent, where the universe offers no light, no movement, no structure. It is not just emptiness, it is silence. A silence that feels intentional. A silence that invites questions no one wants to answer. And in this silence, astronomers felt the first tremor of fear. Could this void be unnatural? This possibility lingered like a shadow. The universe, for all its mysteries, tends to follow rules we spend centuries decoding. When a region breaks those rules, it becomes more than a curiosity, it becomes a message. A warning, perhaps, or a clue to forces beyond our understanding. What could erase hundreds of millions of light-years of galaxies? What could reshape the cosmic web on such an unimaginable scale? The plain, unsettling truth is that no one knows. Yet the more researchers examined the void, the more contradictions surfaced. Some edges appeared slightly distorted, as though gravitational forces were tugging unevenly across its boundary. In other areas, faint radiation patterns hinted at disturbances not caused by ordinary matter. These inconsistencies painted a picture not of passive emptiness, but of something dynamic, something in motion. It was a void that felt alive, not in the biological sense, but in the sense that it interacted with its surroundings in ways scientists could not explain. The emotional impact on the scientific community was profound. Awe blended with anxiety. Wonder mixed with an ever-present sense of unease. This was not a discovery that inspired celebration, it inspired caution. Every new observation only deepened the question that no one could escape. Why is the universe missing a piece this large? As the evidence grew, one chilling realization began to form. The void might not be an anomaly. It might be a sign. A sign that the universe is more chaotic, more volatile, and far more mysterious than anyone dared to imagine. And if this void is just the beginning, if more regions like this lie hidden in the darkness, then our understanding of existence itself may be built on fragile assumptions waiting to collapse. The universe should be full. But here, in this colossal absence, something is wrong. And whatever hides in this emptiness, whether natural, exotic, or unimaginable, forces us to confront a terrifying possibility. The cosmos we thought we understood may be only a thin surface above a much deeper, much darker reality. The night the data first appeared on the astronomers' screens was ordinary in every way, and yet it became the beginning of a cosmic horror story no one had anticipated. Rows of numbers, charts, and plots scrolled past in the sterile glow of laboratory monitors, a routine part of sifting through the vast cosmic surveys collected over decades. Teams had gathered at observatories and research centers across the world, each member immersed in their familiar world of cold, logical data analysis. They were expecting anomalies, perhaps, but nothing prepared them for the stark emptiness that suddenly materialized before their eyes. It wasn't a misalignment of sensors or a glitch in the telescope software. It was real. Vast, cavernous, and unimaginable, a void stretching 300 million light-years across, a scale so immense that it defied immediate comprehension. For a moment there was silence. Not the kind of quiet that blankets a room, but the heavier, almost oppressive kind that comes with the recognition of something deeply wrong. Senior astronomers exchanged glances, hands frozen over keyboards, eyes wide with disbelief. It was as if the universe itself had been holding a secret, and in that instant, it had finally whispered it aloud. No one could reconcile the sight with the well-established models of cosmic structure. A void this massive shouldn't exist, at least not according to everything humanity had painstakingly pieced together about the evolution of galaxies, dark matter, and the cosmic web. Yet here it was, a gaping wound in the fabric of space. Excitement mingled with fear. Within minutes, team members were verifying the readings, double-checking the coordinates, reviewing raw data from multiple observatories, and comparing it to historical sky surveys. The numbers did not lie. Not only was the void enormous, but it appeared impossibly empty. Regions of the universe that should have teemed with billions of galaxies were barren. Instruments that detected mass, gravitational effects, and the subtle distortions of light all indicated the same terrifying truth. This was a region of extreme absence. In the sterile, precise language of physics, it was called a supervoid, but the term felt woefully inadequate. It did not capture the sense of dread that seeped into the minds of those staring at the monitors. Word spread quickly through the scientific community, first as whispers, then as urgent phone calls and emails punctuated by disbelief. Conferences erupted in impromptu sessions, where leading cosmologists pored over graphs and simulations. Every conceivable explanation was considered, Data corruption, observational error, instrumental failure. Each hypothesis was examined and discarded one by one. The void persisted, stubborn and undeniable. And as the reality of the discovery sank in, a different kind of fear took root, the fear of the unknown. This was not merely a missing cluster of galaxies or a quiet patch of space. It was an anomaly so profound that it seemed to challenge the very laws that govern cosmic formation. Something about it was wrong. To understand the magnitude of this discovery, one had to visualize it in human terms. 300 million light-years is nearly inconceivable, a span that dwarfs the scale of our own Milky Way galaxy 100,000 times over. Within this enormous bubble, the cosmic web that normally cradles galaxies and clusters of stars is absent. No swirling arms of galaxies, no intricate filaments of dark matter, not even the faintest traces of intergalactic gas. It is, in a sense, a vast cosmic silence, stretching across unimaginable distances, punctuated only by the faint outlines of the surrounding universe. It is as if nature itself had excised a section of reality, leaving behind a hollow echo that resonates with the unanswerable questions of existence. The emotional response among astronomers was immediate and intense. A mixture of awe, confusion, and even terror coursed through those who first encountered the data. The more they tried to rationalize it, the more elusive the answers became. Every model of cosmic evolution suggested that matter should be present. Galaxies, dark matter, radiation. All of it should have formed clusters, sheets, and filaments in a predictable, quantifiable pattern. And yet, against all odds, there was nothing. Even more disconcerting were subtle hints at irregularities around the edges of the void, small distortions in galactic motions that hinted at something lurking beyond perception. Was it a natural phenomenon, or could it be evidence of forces far stranger than anything yet considered? As discussions deepened, a new kind of tension emerged, the existential dread of confronting a universe that could defy human comprehension. Scientists, normally armed with equations and simulations to predict cosmic behavior, now faced a phenomenon that resisted all frameworks. To many, it was as if they had stumbled upon the universe's own private joke, a region so vast, so empty, it seemed to mock their certainty. For weeks, debates raged over theoretical papers, peer reviews and high-resolution imaging analyses. Some suggested the void was a chance alignment, a statistical fluke. Others feared it might hint at new physics, perhaps even forces or structures that had remained hidden from human eyes for billions of years. No consensus could be reached. Meanwhile, the story leaked beyond the walls of observatories. The media, always hungry for cosmic drama, began framing the discovery with sensationalist tones. A hole in the universe, or a black scar across space. While these descriptions lacked scientific nuance, they captured the public imagination in a way no technical paper could. The void became a symbol, a cinematic canvas upon which both awe and fear were projected. Artists, writers and filmmakers found inspiration in its sheer scale and mystery, envisioning a universe that was not only vast but eerily punctuated by absences that defied logic. Even in scientific circles, it became a source of storytelling, a tangible example of how the cosmos could surprise, frighten, and inspire all at once. Yet amid the awe and speculation, the practical work continued. Astronomers plotted follow-up observations, deployed more sensitive instruments, and expanded surveys to determine if this void was a singular phenomenon or part of a larger pattern. Each analysis reinforced the initial discovery: the void was real, enormous, and inexplicable. Researchers began cataloging every feature, every faint glimmer at its edges, searching for anomalies in light, matter, and radiation. It became a monumental collaborative effort, stretching across continents and involving hundreds of scientists working in synchronized vigilance. Each piece of data added both clarity and deeper mystery, like flickers of light that revealed the shape of a shadowy labyrinth no one had yet fully mapped. And so, what began as routine observation evolved into a story that would haunt cosmologists for years to come. The void challenged their understanding of physics, of the universe's structure, and even of reality itself. In that cold, quiet night when the first numbers appeared, humanity glimpsed a region of space so empty, so massive, that it forced a confrontation with the limits of comprehension. It was a discovery nobody wanted, because it demanded answers that science could not yet provide, questions that might never be fully resolved, and a confrontation with the terrifying possibility that the universe is far stranger and far less predictable than we have ever imagined. And as the astronomers stared at the glowing monitors, they could not escape the gnawing sense that the universe had opened a door to a secret that, once seen, could never be unseen. The void was not merely an absence, it was an enigma, a silent scream across space, a riddle written in the dark between the stars, daring humanity to understand or be consumed by the unknown. The moment one tries to visualize the void, reality strains against the imagination. 300 million light-years is not a distance easily comprehended, yet within that staggering scale lies something that challenges everything we understand about cosmic architecture. The universe, as we have long modeled it, is a tapestry of galaxies, clusters, and filaments, matter woven together by gravity in a delicate yet predictable web. And yet here, in this vast region of space, that tapestry is ripped clean, leaving nothing but an eerie emptiness that stretches beyond the limits of even the most powerful telescopes. To look at it is to witness an absence so profound that the mind struggles to anchor itself in familiar concepts. The edges of the void are equally unnerving. Unlike ordinary cosmic emptiness, which fades gradually into surrounding matter, this supervoid has sharp, almost unnatural boundaries. Galaxies at the periphery appear distorted, subtly tugged toward the void or away from it, as if invisible forces manipulate them. Observers describe the effect as a gravitational mirage, a visual cue that something unseen governs the dynamics of this space. The distortions are not dramatic, barely noticeable on a single frame, but when mapped over hundreds of millions of light-years, they suggest patterns that defy conventional physics. It is as though the universe itself is whispering that this is not a simple anomaly but a profound, structural impossibility. Scientists have tried to measure the void's mass, or more accurately, the lack of it. Gravitational lensing, the bending of light around matter, should reveal subtle concentrations even in low-density regions. Yet here the effect is minimal, almost non-existent. The void behaves as if it is a true absence, a pocket of space where matter refuses to exist. The scale of emptiness creates a paradox. Cosmic structures nearby exert normal gravitational influence, but inside the laws appear to bend. It is not simply a less crowded region. It is a region where the universe's own rules seem to falter, leaving a dark question mark against the canvas of spacetime. Even more disturbing is the consistency of its emptiness. Normally, voids in space are sprinkled with small galaxies, wisps of gas, or dark matter that escape casual observation. But surveys reveal nothing. Not a faint galaxy cluster, not a stray cloud of intergalactic gas, not a measurable hint of dark matter to explain gravitational anomalies. It is a pristine absence, a cosmic cavity stripped bare. The emptiness challenges the fundamental assumption that matter naturally fills the universe. This void is so large and so complete that it forces a confrontation with the possibility that some unknown process, some force or mechanism beyond human comprehension, has sculpted it deliberately, erasing matter across hundreds of millions of light-years. Visualizing the void is both beautiful and terrifying. Imagine a cosmic ocean suddenly torn open, a sea of stars and galaxies receding into a vast, dark depression. Its sheer scale dwarfs familiar celestial structures. Entire galactic superclusters vanish within its emptiness. The edges glow with faint galactic light, halos that mark where known physics still operates, yet inside darkness dominates. In cinematic terms, it is the ultimate contrast, a universe of infinite splendor interrupted by a yawning, unyielding absence. Every attempt to explain it feels inadequate, as if the mind insists on filling the void with something familiar, only to be met with the unyielding truth that it is nothingness made manifest. Researchers also note subtle temperature differences at the void's boundaries. Cosmic microwave background radiation, the faint afterglow of the Big Bang, behaves strangely when passing through this region. Slight cooling effects are observed, minor but significant enough to hint at interactions that science cannot fully account for. These variations, almost imperceptible at first, have profound implications. They suggest the void is not merely an empty hole but an active participant in the cosmic narrative, subtly influencing light, gravity, and perhaps even the underlying fabric of space itself. The more data is collected, the more the void resists interpretation, teasing scientists with patterns that do not match any known model. The psychological impact on the scientific community cannot be understated. Humans are accustomed to understanding the universe through patterns, predictability, and laws that govern the behavior of matter and energy. A void this enormous, with such stark emptiness, shatters that expectation. It is not simply the absence of galaxies or stars, it is an absence of certainty, a space where the universe's principles seem to falter. In this sense, the void becomes more than a physical phenomenon. It becomes a symbol of the unknown, a reminder that even in the age of satellites, supercomputers, and high-resolution telescopes, the cosmos can still confront us with enigmas beyond comprehension. And yet, as terrifying as it is, the void demands attention. Scientists cannot ignore it. Its very existence challenges the foundations of cosmology. It is a riddle that must be solved, a puzzle whose pieces stretch across hundreds of millions of light-years and defy conventional logic. Each observation, each measurement, each faint trace at its periphery offers clues, yet none provide answers. The void looms large not only in space but in the imagination, a silent giant whose emptiness resonates louder than any star. It is a reminder that in the vast expanse of the universe, some mysteries are so immense, so absolute, that they compel both fear and fascination simultaneously. By the end of the analyses, one truth becomes clear. This is not a small cosmic accident. The void is deliberate in its scale, profound in its emptiness, and impossible to overlook. Its enormity forces a re-evaluation of everything previously assumed about cosmic structure and matter distribution. It is not just a hole in space, it is a wound in the narrative of the universe, a gap that dares humanity to fill it with understanding. The challenge now is to peer deeper, to seek what may lie hidden at its edges, and to confront the possibility that inside this emptiness lies a truth far more terrifying than mere absence. A void that may hold secrets capable of rewriting our understanding of reality itself. The universe is in many ways defined by what is present. The galaxies, stars, planets, gas clouds, and dark matter that shape cosmic evolution. Yet sometimes, the story of the cosmos is told more vividly by what is missing. The discovery of the enormous supervoid brought this lesson into stark relief. Not only is there an extraordinary emptiness stretching 300 million light-years, but the region seems to defy expectations at every level of cosmic composition. Matter, both ordinary and dark, is conspicuously absent, leaving scientists to grapple with a question that is as terrifying as it is confounding. Where did it go and why? The missing matter problem begins with baryonic matter, the ordinary matter composed of protons, neutrons, and electrons that forms everything we see and touch. Across the universe, galaxies trace filaments of this matter, clustering into groups and superclusters, leaving voids that are still populated with faint traces of gas and dust. But in this supervoid, even these residual signals are astonishingly absent. Observations using spectroscopic surveys and X-ray telescopes reveal a region devoid of the diffuse gas that normally fills intergalactic space. It is as though the cosmic web, the intricate network of matter that holds the universe together, has been surgically excised, leaving behind an unbroken vacuum. The sheer scale of this emptiness challenges the assumptions of standard cosmology. How could matter be so thoroughly absent across hundreds of millions of light-years? The mystery deepens when dark matter is considered. Dark matter, invisible yet detectable through its gravitational influence, is thought to form the scaffolding upon which galaxies build themselves. In normal voids, dark matter is present, albeit at lower densities, exerting subtle gravitational effects that influence nearby structures. Yet within this supervoid, the expected gravitational signature of dark matter is almost entirely missing. Light from distant galaxies does not bend in the expected ways. Gravitational lensing studies reveal an absence of mass where it should exist. This is not merely a region with less matter. It is a region where the universe's hidden skeleton appears to have been erased. The implications are staggering. The supervoid may not just be an empty region. It may be a place where fundamental components of the cosmos themselves are absent, bending or breaking the rules of known physics. Scientists have spent months modeling possible explanations, but each theory encounters insurmountable challenges. One possibility is that the void represents a statistical anomaly, a rare, extreme fluctuation in the density of matter across the cosmos. In principle, such fluctuations can occur, but the probability of an absence of this magnitude is vanishingly small. Even the most extreme models of cosmic variance cannot produce a void this enormous, a region so thoroughly cleansed of matter. Another possibility is observational error. Perhaps instruments fail to detect faint signals, or surveys missed subtle structures. But the data has been cross-verified with multiple telescopes, wavelengths, and independent teams, all converging on the same horrifying conclusion. The void is real, and it is emptier than any region of space ever catalogued. The emotional impact on the scientific community has been profound. Cosmologists are trained to understand the universe as a system of predictable rules. Gravity shapes matter, matter shapes galaxies, galaxies trace filaments of the cosmic web. A region where both baryonic and dark matter are missing disrupts this orderly narrative. It is not simply a challenge to current theories, it is a confrontation with uncertainty at the deepest level. The void becomes a symbol of cosmic unpredictability, a place where the universe seems to have abandoned the rules that govern everything else. For those who study the heavens, it is a humbling reminder of how much remains unknown, and how fragile our understanding truly is. The problem is further compounded by indirect evidence from cosmic microwave background, CMB, radiation. Light from the early universe travels billions of years to reach Earth, passing through regions of varying density along the way. In typical voids, this radiation shows subtle cooling or temperature variations as it traverses under dense regions. But the supervoid produces effects that are slightly more pronounced than models predict. The magnitude of the CMB cold spot associated with this void suggests that the underdensity is extreme, perhaps beyond what the standard cosmological framework can explain. It raises an unsettling question. Is the void a natural consequence of cosmic evolution, or is something actively shaping it, something invisible yet powerful enough to remove both visible and dark matter from a vast region of space? Theories have begun to edge into speculative territory. Some suggest that exotic forms of matter or energy could be at play, altering the distribution of mass in ways conventional physics cannot account for. Others propose that the void may be evidence of large-scale interactions with hidden dimensions, or even remnants of events from an earlier cosmic epoch that left scars on the universe itself. While these ideas remain unproven, they underscore the profound mystery. The missing matter problem is not just a puzzle about absence. It is a puzzle that could rewrite the laws of physics as we know them. Each new observation strengthens the case that the void is an active anomaly, not a passive empty space. The human response to the void is as fascinating as the science itself. In the quiet of their observatories, scientists wrestle with the existential weight of staring into a region of space that contains almost nothing, yet hints at forces beyond comprehension. The scale of the void magnifies the psychological impact. To peer into a space hundreds of millions of light-years across and see nothing is to confront the literal emptiness of the universe. It evokes awe, fear, and a sense of vulnerability, revealing how deeply our perception of reality is tied to the presence of matter, structure, and the predictability of natural laws. As investigations continue, the missing matter problem remains central to understanding the void. Each measurement, simulation, and theory points toward the same conclusion. This is no ordinary cosmic absence. It is an extreme anomaly, a massive emptiness where matter, both visible and invisible, should exist but does not. It forces a reckoning with the limits of human knowledge, challenging assumptions about gravity, dark matter, and the cosmic web. And it raises the most haunting question of all. If such a vast region of space can be emptied of matter, what else might the universe be hiding in plain sight? The supervoid, in all its terrifying emptiness, is not simply a cosmic curiosity, it is a window into the unknown, a silent challenge to our understanding, and perhaps a warning that the universe contains mysteries far larger and more dangerous than we have ever imagined. The void, massive and seemingly empty, is not merely a region devoid of matter. It is also a place where energy behaves strangely, subtly bending the rules of the cosmos. One of the most compelling suspects in explaining the mystery is dark energy, the elusive force responsible for the accelerated expansion of the universe. Normally, dark energy is uniform, a quiet background hum pushing galaxies apart at a steady, predictable rate. But within the supervoid, some astronomers suspect that this force is amplified, behaving differently than it does in surrounding regions. The notion is subtle, almost imperceptible, yet its implications are monumental. If dark energy is acting unusually here, it could be reshaping space itself, stretching and thinning the cosmic fabric in ways humanity has never witnessed before. Observations suggest that light traveling through the void experiences minuscule distortions and delays. Photons from distant galaxies seem to arrive slightly earlier or later than expected, and their redshift, the stretching of light due to cosmic expansion, behaves in unexpected ways. While these effects are tiny, they accumulate over hundreds of millions of light-years, producing measurable discrepancies that hint at an unusual energy landscape. Scientists describe it as a whisper of dark energy, faint but insistent, a force acting in silence across a staggering emptiness. It is as though the void is not a passive nothingness but a space alive with subtle dynamics, quietly reshaping itself under the influence of hidden energy. The cinematic image of this phenomenon is haunting. Imagine a region of the universe where space itself seems to expand slightly faster than elsewhere, where galaxies at the periphery drift with unusual acceleration, their motions governed by invisible hands. The void becomes a stretching canvas, pulling light, matter, and perhaps even the underlying spacetime fabric toward an unknown direction. Unlike black holes, which trap matter and bend space dramatically, This supervoid exerts its influence in a gentle yet inexorable manner, amplifying the sense of cosmic unease. It is a place where the rules feel familiar but are subtly twisted, where the universe behaves like a living, breathing entity with secrets of its own. The implications of this energy distortion extend beyond mere curiosity. They challenge fundamental assumptions in cosmology. Dark energy, while mysterious, is treated as a constant in most models, evenly distributed and predictable. But if the supervoid contains pockets of intensified or otherwise altered dark energy, then our understanding of cosmic expansion could be incomplete. The void might act as a natural laboratory, a rare and extreme environment where the universe experiments with its own laws. Some theorists even speculate that if such voids are widespread, they could cumulatively influence the large-scale structure of the cosmos in ways that have yet to be fully mapped or understood. This possibility is both thrilling and terrifying, suggesting that the void may not simply be a passive space but an active agent in the evolution of the universe. Astronomers have turned to simulations to try to understand these whispers. Advanced computational models recreate the void, adjusting variables to account for both visible and dark matter, or the startling absence thereof, while introducing variations in dark energy density. These simulations reveal subtle patterns, regions where light bends slightly, where the void's edges interact with surrounding filaments more dynamically than theory predicts, and where expansion may be slightly faster than in ordinary cosmic space. It is a delicate dance, almost imperceptible on short timescales but profound over millions of years. Each simulation reinforces the notion that this is not a conventional void but a space where energy, gravity, and matter interact in extraordinary ways. Yet despite these insights, the void retains its chilling mystery. The effects of dark energy are subtle, almost ghost-like, and cannot be fully captured by current instruments. Even the most sensitive telescopes struggle to detect the faint deviations in galaxy motion or photon arrival that hint at its influence. The void, in this sense, is a cosmic paradox. Enormous, empty, and yet teeming with subtle forces that elude comprehension. Its silence is deceptive, a quiet tension that hums beneath the surface, reminding humanity that the universe may contain dynamics far beyond the limits of observation. Every new measurement brings excitement and fear, for the whispers of dark energy suggest that the void is alive in ways no one fully understands. Philosophically, the void challenges our perception of emptiness. We often imagine space as a vacuum, a sterile backdrop against which celestial dramas unfold. But this supervoid suggests that emptiness itself may be an active participant in cosmic events. Dark energy, normally invisible and uniform, may find an unusual expression here, bending spacetime in a subtle crescendo of motion. In cinematic terms, the void becomes a vast stage, not of chaos or destruction, but of eerie, slow-motion transformation, a place where the universe's invisible currents play out over timescales incomprehensible to human experience. It evokes awe, a sense of profound insignificance, and a lingering unease that something fundamental is both hidden and powerful. Speculation extends even further. Some theorists propose that the void could represent a glimpse into a region of the universe where dark energy dominates entirely, a place almost disconnected from normal matter. Could it be that the void is a window into a different state of reality, a territory where the known rules of physics are secondary to exotic forces that sculpt the cosmos silently? While no concrete evidence exists for such ideas, the sheer scale of the supervoid and the subtle anomalies observed lend them a weight that cannot be dismissed outright. In a way, the void serves as a reminder that the universe has always been stranger than humans expect, and that even vast emptiness can harbor secrets of cosmic magnitude. The whispers of dark energy also raise haunting questions about the future. If this region of intensified or unusual energy continues to expand, could it influence neighboring structures over eons? Could it slowly stretch, distort, or even erode the surrounding cosmic web? Observations cannot yet answer these questions definitively, but the possibilities create a tension between curiosity and fear. Scientists and lay observers alike are forced to confront the paradoxical nature of the void. It is simultaneously an absence and a presence, a silent nothingness that shapes everything around it, and a reminder that the universe operates on scales and forces beyond human comprehension. And so the supervoid, silent and vast, becomes a theater of subtle cosmic drama. Dark energy whispers through it, unseen yet unmistakable, bending light, stretching space-time, and challenging every assumption about emptiness. The void is no longer merely a gap in the universe, it is a region alive with hidden dynamics, a place where the laws of physics may flex in ways humanity cannot yet fully measure. In contemplating the void, we glimpse a truth as humbling as it is terrifying. Emptiness is never truly empty, and the universe contains forces that whisper in shadows, waiting for humanity to notice, or to be overwhelmed by their quiet, inexorable power. While the supervoid itself dominates with an unsettling emptiness, its edges reveal a subtle yet haunting spectacle. Here, at the margins where light from ordinary space meets the yawning absence, astronomers have detected what they call ghost galaxies, faint, almost spectral galaxies that seem to defy the natural laws governing cosmic motion. Unlike typical galaxies, which follow predictable orbits within clusters or along filaments, these edge galaxies exhibit unusual shapes, elongated structures, and motions that suggest they are being influenced by something invisible within the void. Observers describe them as ethereal, as if the void itself is tugging at the very fabric of their existence, drawing them into a slow, silent dance along its perimeter. Visualizing these ghost galaxies is both eerie and mesmerizing. Imagine faint clusters of stars stretched into ribbons, their spiral arms pulled taut as though by invisible strings. Some appear twisted, distorted into shapes that make little sense according to conventional physics. Yet they persist, shimmering faintly in the darkness, stubborn testaments to the fact that even at the edge of absolute emptiness, traces of matter cling to life. The cinematic effect is striking, a field of fragile light bending around the void, highlighting the stark contrast between presence and absence, between the familiar order of galaxies and the incomprehensible vastness beyond. It is a vision that evokes both awe and unease, a liminal zone where the universe's rules are stretched but not yet broken. The motions of these ghost galaxies are perhaps the most perplexing aspect. Studies show that some are drifting away from the void center, while others appear to be curving toward it, as if responding to an unseen gravitational pull. The distortions are subtle but measurable, accumulating across hundreds of millions of light-years. Researchers speculate that these anomalies might reveal the presence of hidden mass or energy within the void itself, forces undetectable by ordinary instruments yet powerful enough to influence galactic trajectories. This adds a layer of mystery. Is the void truly empty, or does it conceal structures or energies that remain invisible, whispering their presence through the motion of these fragile, ghostly galaxies? The edge of the void, where these galaxies reside, acts as a natural boundary, a place where the known and the unknown collide. The galaxies themselves become cosmic messengers, carrying clues about the forces at play inside the void. By mapping their motion, shape, and distribution, astronomers hope to infer the properties of whatever lies within the emptiness. The process is painstaking, requiring precision measurements and decades of cumulative data, yet even these faint signals hint at profound truths. Every twist in a spiral arm, every slight deviation from expected motion, is a piece of a puzzle that may reveal how the void interacts with surrounding space, how it might have formed, and whether it hides mechanisms or phenomena yet unknown. The ghost galaxies also provide a visual and conceptual bridge between fear and understanding. Their presence reminds observers that even in regions dominated by absence, the universe finds a way to manifest subtle structure. They are the fragile skeletons of light clinging to the edges of nothingness, a poetic counterpoint to the stark void at their center. Yet their ethereal beauty is tinged with unease. For the galaxies to behave this way, something extraordinary must be influencing them, something that challenges the uniformity of space, something that implies the universe is more complex, more alive, and more dangerous than previously imagined. They hint at forces that cannot be seen directly, yet are undeniable in their effects. Astronomers have begun comparing these ghost galaxies to their counterparts in ordinary voids elsewhere in the cosmos. In smaller, more typical voids, galaxies are sparse but still behave in predictable ways, drifting gently along gravitational gradients and maintaining relatively normal morphology. The ghost galaxies at the edges of this supervoid, however, break these conventions. Their shapes are inconsistent, their paths erratic, and their interactions with nearby matter suggest influences far beyond the expected. These differences reinforce the idea that the supervoid is exceptional, not merely in its emptiness, but in its active influence on the surrounding universe. It is a space that seems to reach outward, subtly shaping reality at its boundaries. The cinematic imagery of ghost galaxies moving along the periphery of a massive void also carries symbolic weight. In one sense, they are survivors, existing at the threshold of annihilation, caught between the emptiness of the void and the fullness of the universe. In another sense, they are harbingers, signaling that the void is not inert, that it possesses a presence, however hidden, that can exert influence over vast distances. For viewers, this contrast is gripping. the delicate beauty of the galaxies against the terrifying scale of emptiness creates tension, drama, and a sense of cosmic narrative unfolding on an unimaginable scale. It is a story of fragility, resilience, and hidden forces, told in the silent language of motion and light. The study of these galaxies has also raised philosophical and speculative questions. If a region of space this empty can influence nearby structures, what does it imply about the universe as a whole? Could other voids exert similar effects, shaping the distribution of matter in ways humans have yet to detect? Are ghost galaxies a common feature at the edges of cosmic emptiness, or are they unique to this supervoid? Each question pushes the boundaries of knowledge, blending observational astronomy with deep theoretical inquiry. The void, by its very emptiness, becomes a mirror reflecting the limits of human understanding and the tantalizing hints of mysteries that stretch across billions of light years. Yet, despite the uncertainty, the ghost galaxies remain measurable and real. They serve as touchstones for scientific investigation, faint lighthouses guiding astronomers toward understanding the invisible. Their behavior suggests that whatever lurks within the supervoid is not entirely beyond comprehension. Through patient observation, modeling, and analysis, scientists hope to piece together the unseen forces at play, to transform speculation into knowledge, and to map the contours of a cosmic mystery that might otherwise remain hidden. Each galaxy is a clue, a fragile indicator of the void's influence, carrying with it a story written in stars and stretched across incomprehensible distances. In the end, the ghost galaxies at the edge of the supervoid are both beautiful and unsettling. They exist at the boundary between known and unknown, between light and darkness, between presence and absence. They embody the paradox of the void itself, a space that appears empty yet exerts influence, a region where matter is missing, yet where subtle motion reveals the hidden forces within. Observing them is to confront the delicate tension between awe and fear, wonder and terror, knowledge and ignorance. They remind humanity that the universe is never simple, that even at the edges of nothingness, profound mysteries await those who dare to look closely, and that in the quiet movements of ghostly galaxies, the universe whispers its most unsettling secrets. The universe is a master of patterns, a grand tapestry woven from galaxies, clusters, and filaments stretching across unimaginable distances. For decades, cosmologists have studied the cosmic web, mapping its intricate structures, predicting the distribution of matter with remarkable precision, and using these patterns to confirm the underlying laws of physics. Yet in the midst of this order, the supervoid stands as a defiant anomaly, a colossal absence that should not exist according to any known model. Its scale alone is enough to unsettle even the most seasoned scientists, hundreds of millions of light-years devoid of matter, both visible and invisible, a yawning emptiness that seems to mock our understanding of cosmic evolution. Comparisons with known voids make its extraordinariness even clearer. Smaller voids are common in the universe. They form naturally when gravitational forces pull matter into clusters, leaving underdense regions behind. But these typical voids are populated by residual galaxies and subtle filaments of dark matter that maintain some structure, however faint. The supervoid, by contrast, is striking in its completeness. Surveys across multiple wavelengths and instruments have failed to detect even the faintest glimmer of matter within it. It is not merely empty, it is an extreme, almost unnatural, absence that defies probabilistic expectations. Statistically, such a void should be extraordinarily rare, bordering on impossible, yet here it is, stretching across the cosmos as if to challenge every assumption we have made about how the universe organizes itself. The question of its origin immediately arises. How could such an immense void form? Standard cosmological models rely on the gravitational clumping of matter and the expansion of space over billions of years. Even in regions of low density, simulations predict that some galaxies, dark matter, or intergalactic gas would persist. The supervoid, however, shows no evidence of these remnants. Its edges are sharp, its interior empty, and its gravitational influence on nearby galaxies is anomalous. Every attempt to simulate its formation using current theories ends in failure. Either the void does not reach the observed size, or matter appears where it should not. It is a cosmic puzzle, a contradiction that forces scientists to consider ideas that were previously relegated to speculation. The void's existence is not merely a curiosity, it raises profound questions about the nature of reality itself. If the universe can produce a structure so improbable, it implies that our understanding of cosmic evolution is incomplete. Perhaps the laws of physics are not as uniform as we assume, or perhaps unknown forces act on vast scales in ways that subtly sculpt the cosmos. Some theorists have suggested that the void could be evidence of exotic phenomena, from unusual dark energy distributions to interactions with hidden dimensions. Others have even entertained the possibility of influences from other universes, colliding with our own in ancient epochs and leaving behind scars visible only now. While such ideas are speculative, the mere existence of the supervoid forces their consideration, blurring the line between science and what might once have seemed the realm of science fiction. Observational evidence continues to reinforce the anomaly. The cosmic microwave background, CMB, the afterglow of the Big Bang, reveals subtle temperature variations when observed through the void. These cold spots, minor on small scales but significant when viewed over hundreds of millions of light-years, suggest that the void is more than just an absence of matter. It may actively interact with the universe on fundamental levels. Light traveling through the void experiences effects that deviate from expectations, hinting at interactions between space itself and the forces contained within or around it. The supervoid is, in this sense, a dynamic absence, a space that seems to exert subtle influence despite the emptiness at its core. The scale and completeness of the supervoid have prompted intense scrutiny and debate. Cosmologists compare its characteristics to predictions from the lambda cold dark matter model, the reigning framework for understanding the universe. While the model predicts the existence of voids, it does not allow for a region of this magnitude to remain so completely devoid of matter. The discrepancy is stark, forcing a re-evaluation of assumptions about density fluctuations in the early universe, the behavior of dark energy, and the possible presence of forces or structures previously unknown. Each new study raises further questions, deepening the mystery and highlighting the inadequacy of current theories to account for such an extreme anomaly. The cinematic impact of the supervoid is striking. Imagine, on the cosmic scale, a yawning cavity that stretches across hundreds of millions of light-years, a region of nothingness surrounded by the intricate web of galaxies, clusters, and filaments. Its vastness emphasizes the fragility of order in the universe, a reminder that even in a cosmos governed by predictable laws, extremes exist that challenge comprehension. The void is simultaneously beautiful and terrifying, a paradoxical space that evokes awe for its scale and unease for its defiance of understanding. It is a scene of cosmic drama, a visual and intellectual reminder of the universe's capacity to surprise and unsettle. Perhaps most unsettling is the suggestion that this is not an isolated phenomenon. Smaller voids are known, but if regions like the supervoid are more common than previously thought, the implications for cosmology are profound. Our models of matter distribution, galaxy formation, and dark energy may require significant revision. The supervoid may be a harbinger, a signpost pointing to gaps in human knowledge and the limits of observational astronomy. It forces a confrontation with the unknown, a stark realization that the universe may hold secrets of scale, structure, and energy far beyond what current science can explain. In the end, the supervoid's existence challenges not only our theories but also our perception of reality. It is a monument to the extremes of cosmic structure, an anomaly that stretches imagination and demands new ways of thinking. For scientists, it is a problem to solve, a riddle in the grand story of the universe. For the rest of us, it is a reminder of our smallness in a cosmos that contains both order and defiance, structure and empty extremity. The supervoid should not exist, and yet it does, a silent, massive testament to the universe's ability to surprise, to unsettle, and to inspire a profound sense of wonder at the mysteries that remain hidden in the vast darkness of space. The universe carries its history in subtle whispers, echoes of events from the earliest moments after the Big Bang, etched into the faint glow of the cosmic microwave background. This afterglow, a relic of a universe just 380,000 years old, provides a cosmic map that reveals both the familiar and the inexplicable. Among its most puzzling features is the cold spot, a vast region of slightly cooler temperatures, a subtle anomaly stretching across more than 1 billion light-years. For years, scientists debated its origin, considering everything from statistical flukes to exotic physics. Yet the discovery of the supervoid with which it may align adds a new, unsettling dimension. What if the cold spot is more than a temperature fluctuation? What if it is the faint signature of an enormous absence, a cosmic wound carved into the universe long before life, galaxies, or stars existed? The connection between the supervoid and the cold spot is both tantalizing and mysterious. Observationally, the void appears roughly in the direction of the cold spot, a coincidence that is statistically improbable and therefore worthy of attention. The void itself is not merely empty, it is a region where the density of matter, both baryonic and dark, is extraordinarily low. Light from the early universe, passing through this emptiness over billions of years, would experience subtle shifts in energy, a process known as the integrated Sachs-Wolf effect. This effect slightly cools the cosmic microwave background photons, producing a cold imprint that could correspond to the cold spot we observe today. In this way, the supervoid may act as a ghostly brushstroke, painting the universe with a shadow that has endured for eons, invisible to the naked eye yet profound in its implications. Visualizing this connection is both cinematic and unsettling. Imagine photons of ancient light traveling for 13.8 billion years, traversing the cosmic web, only to pass through a region where the gravitational influence of matter is anomalously weak. Their energy shifts subtly, imperceptibly, leaving behind a cold mark in the afterglow of creation. To stand on Earth and detect this pattern is to engage in a kind of cosmic archaeology, reading the faint fingerprints left by an emptiness so vast that it challenges comprehension. The cold spot becomes a spectral signal, a whisper of the supervoid's presence, linking the early universe to the present day and suggesting that even the universe's oldest light carries traces of contemporary cosmic anomalies. Yet the implications go deeper than observational astronomy. The existence of the cold spot, aligned with the supervoid, hints at the universe's capacity for extremes. It is not merely that matter is missing. It is that the absence of matter can leave a measurable imprint across billions of light years, influencing phenomena from the dawn of time to the present. This raises profound questions about the nature of cosmic structure. How are voids formed on such a scale? Could a region so empty affect the evolution of surrounding galaxies, filaments, or even the expansion of space itself? And perhaps most unsettling, if the cold spot and supervoid are connected, what does this suggest about the stability of the universe? Could other voids, unseen and unmeasured, imprint themselves on the cosmos in ways that subtly alter its trajectory, hinting at forces or events beyond human understanding? The discovery also challenges statistical expectations. When the cosmic microwave background is analyzed, temperature fluctuations are expected to occur randomly within a certain range. The cold spot, however, stands out as an extreme anomaly, with a deviation far beyond what conventional models predict. The supervoid in this context offers a partial explanation, but not a complete one. While the presence of the void can account for some cooling, it does not fully explain the magnitude or extent of the cold spot. This mismatch suggests that the universe may hold additional, hidden factors influencing the temperature of the CMB. Perhaps the void contains unseen forces or structures. Or perhaps the early universe itself underwent events we are only beginning to theorize about. Each possibility stretches the imagination, blending cosmology, physics, and philosophy into a single, intricate puzzle. The historical context of the cold spot amplifies its significance. Since its first detection in data from the Wilkinson Microwave Anisotropy Probe and later confirmed by the Planck satellite, it has been a source of intense debate. Theories ranged from the mundane, a statistical fluke, to the extraordinary, signs of collisions with other universes or imprints of massive structures beyond our observable horizon. The alignment with the supervoid now gives credence to more grounded, yet still astonishing explanations. It is a rare moment where observational evidence begins to converge with theoretical speculation, creating a tangible link between a vast cosmic emptiness and the most ancient light in the universe. This connection transforms the cold spot from a curious anomaly into a window onto phenomena that challenge the boundaries of human comprehension. The cinematic potential of the cold spot and supervoid connection is undeniable. One can imagine a vast map of the cosmic microwave background, dotted with the delicate fluctuations that encode the story of the universe. Across this map, the cold spot appears as a muted scar, a subtle but distinct depression in the glow, a shadow cast by the enormous void stretching hundreds of millions of light years. It is a visual metaphor for absence and presence, for mystery and revelation. The void itself may be unseen in conventional images, yet its influence is unmistakable, a reminder that even emptiness can wield power across cosmic time and space. Philosophically, the cold spot challenges humanity's conception of order and predictability. We often think of the universe as governed by neat rules, where matter clumps, stars form, and galaxies spin predictably within cosmic filaments. Yet the cold spot, linked to the supervoid, suggests that the universe contains anomalies, regions that resist expectation and logic. It is a humbling realization, one that confronts us with the limitations of our understanding and invites contemplation of forces and structures that are vast, ancient, and invisible. The cold spot becomes more than a measurement. It becomes a symbol of the universe's capacity for extremes, a haunting reminder that what is missing can be as significant as what is present. Researchers continue to study this connection with ever-increasing precision. Surveys and simulations aim to refine measurements of the supervoid, its exact dimensions, density, and shape, while observations of the CMB seek to understand the cold spot's full magnitude. Each dataset adds detail, yet also adds complexity, revealing additional irregularities and subtle shifts that deepen the mystery. It is a delicate interplay between observation and theory, a scientific dance in which the universe reveals its secrets incrementally, always leaving a margin of uncertainty. This uncertainty is part of the allure, drawing astronomers, physicists, and curious minds alike into a narrative that spans billions of years and unfathomable distances. Ultimately, the cold spot and supervoid connection embodies a profound contrast: light and darkness, presence and absence, known and unknown. The void may seem empty, yet it leaves an indelible mark on the universe's oldest light. The cold spot may appear subtle, yet it hints at forces of immense scale operating silently across the cosmos. Together they create a narrative of cosmic tension, a story of mystery and revelation that spans space and time. The connection challenges not only scientific understanding but also human imagination, demanding that we consider the universe not as a static backdrop, but as a dynamic, enigmatic, and occasionally terrifying expanse filled with surprises that defy comprehension. The cold spot is not just a cold region in the sky, it is a whisper from the void, a question written in light, daring humanity to look closer, think deeper, and confront the unimaginable vastness of emptiness itself. The supervoid does not merely challenge the laws of physics within our own universe, it opens the door to speculation that reaches far beyond conventional cosmology. One of the most provocative ideas emerging from recent studies is that the void could be a relic of a collision between universes. In theories of the multiverse, our universe is only one bubble among potentially infinite others, each governed by its own laws and expanding in its own spacetime. Occasionally, these cosmic bubbles might come into contact, producing ripples, distortions, or even massive voids within the fabric of our universe. The scale and emptiness of the supervoid make it an intriguing candidate for such an extraordinary event, a scar left by an encounter with something truly alien in both origin and consequence. To understand the concept, imagine two soap bubbles floating and colliding in slow motion. The impact leaves marks, distortions, and regions of thinning where the bubbles merge or repel each other. On a cosmic scale, such a collision would leave a far subtler, yet immensely powerful imprint. The supervoid could represent such a region, an area where the gravitational and energetic forces of a neighboring universe briefly influenced our own, removing matter and altering the flow of dark energy. While the evidence remains circumstantial, the alignment of the supervoid with the cold spot, along with anomalies in the distribution of galaxies at its edge, makes this hypothesis both terrifying and compelling. The implications of a universe-to-universe collision are staggering. For one, it would suggest that our cosmos is not self-contained but part of a larger, interacting system of universes, each capable of influencing the others in subtle or catastrophic ways. The supervoid would then be more than a curious absence. It would be a witness to an event on a scale beyond human comprehension. In this view, the void is not simply a passive space, it is an active record of interactions that occurred billions of years ago, a frozen echo of a contact that may have shaped the evolution of matter, energy, and cosmic structure within our observable universe. Observationally, evidence for such collisions is elusive and difficult to distinguish from other explanations. Some features of the supervoid, such as its sharp boundaries, extreme emptiness, and subtle distortions in nearby galactic motion, could be consistent with a multiversal collision scenario. Light traveling through the void may experience shifts in energy, not solely due to ordinary matter distribution, but due to distortions in the underlying fabric of spacetime caused by an external force. While conventional physics can model parts of these effects, they cannot fully account for the void scale and the anomalies observed at its periphery. This gap in understanding leaves room for the extraordinary hypothesis of multiversal interaction, a possibility that, while speculative, cannot be entirely dismissed. The cinematic imagery of such a collision is both awe-inspiring and unsettling. One can picture a vast, invisible hand sculpting emptiness across hundreds of millions of light-years, a silent force imposing absence upon the otherwise bustling cosmic web. Galaxies at the edge twist and elongate under gravitational strain, while the void itself stretches like a wound in the fabric of the universe. The cold spot, faint and cold, becomes the visible manifestation of this ancient encounter, a ghostly imprint of a cataclysmic event whose direct evidence is beyond human perception. The void, in this sense, is simultaneously a monument, a scar, and a mystery all at once. Philosophically, the possibility of a collision between universes forces a radical rethinking of humanity's place in the cosmos. Our universe, long considered vast and solitary, might instead be one bubble among countless others, each interacting in ways we can barely imagine. The supervoid would be a tangible manifestation of this larger system, a window into forces and scales beyond ordinary comprehension. It challenges the assumption of isolation, suggesting that what lies beyond our observable universe may not only exist but may have left discernible marks within our own spacetime. It is a profound and unsettling notion. Emptiness may be a message and the void a letter from realities beyond our own. Speculation about universe collisions also intersects with the study of dark energy. If such interactions occur, they might locally alter the density and behavior of dark energy, creating subtle anomalies in cosmic expansion. The supervoid could then be understood not just as a vacuum of matter, but as a region shaped by the invisible hand of multiversal forces, where energy, gravity, and spacetime have been subtly rewritten. This interplay between theory and observation highlights the extreme rarity and importance of the void, making it a unique laboratory for exploring physics at scales otherwise inaccessible to human inquiry. In practical terms, proving a collision between universes remains extraordinarily difficult. Instruments can measure galaxy motion, light distortions, and the cosmic microwave background, but directly observing influences from outside our universe is beyond current technology. What scientists can do, however, is carefully analyze anomalies like the supervoid, mapping patterns, and searching for correlations that defy conventional explanations. Each anomaly, each subtle irregularity, is a clue, a potential piece of evidence that, when assembled, could point to interactions with realities beyond our own. The supervoid is, in essence, a cosmic detective story, where emptiness itself leaves the faintest trail for the inquisitive mind to follow. Ultimately, the supervoid as a potential relic of a multiverse collision embodies contrast on every level. Absence versus presence, the visible versus the invisible, the known versus the incomprehensible. It is terrifying in scale, elegant in structure, and deeply mysterious in origin. Whether or not future research confirms the multiverse hypothesis, the supervoid challenges conventional thinking, stretching imagination and scientific inquiry to the limits. It is both a warning and an invitation, a region of emptiness that compels us to confront the possibility that our universe is not alone, and that even absence can carry the fingerprints of unimaginable cosmic-scale events. Standing at the edge of the supervoid is like standing at the border between comprehension and chaos. Unlike ordinary regions of space where galaxies, stars, and clusters form a predictable cosmic web, the periphery of this void feels otherworldly, as if the universe has drawn a line between the familiar and the unfathomable. Here, galaxies behave strangely, light bends in unexpected ways, and the very structure of space seems to stretch and thin. Observing this region is an exercise in both scientific rigor and imagination, as the universe presents phenomena that defy conventional laws while maintaining a delicate, haunting beauty. It is the ultimate threshold, a liminal space where reality itself appears to be tested. Astronomers describe the edge of the void as a zone of extremes. On one side lies the bustling cosmic web, a dense network of galactic clusters, superclusters, and interstellar filaments, all shaped by gravity, dark matter, and dark energy. On the other side lies near total emptiness, hundreds of millions of light-years without detectable baryonic matter, gas, or dark matter. Between these extremes is a boundary that is neither smooth nor uniform. It fluctuates, showing regions where galaxies are elongated, tilted, or subtly distorted, as if the fabric of space is under tension. The contrast is cinematic in its clarity, light against darkness, presence against absence, order against profound anomaly. It is a stage set by nature itself, inviting both awe and deep unease. The behavior of galaxies at the edge further emphasizes the surreal nature of the void. Some galaxies drift slowly away from the void center, pulled outward by gravitational interactions with the surrounding cosmic web. Others seem to curve inward, caught in invisible currents or influenced by forces beyond ordinary understanding. Spiral arms stretch into elongated shapes, dwarf galaxies wobble in irregular orbits, and clusters appear thinner and more diffuse than expected. These anomalies are subtle but measurable, revealing that the void exerts influence even from its emptiness. It is a paradox, a place where nothing exists yet something exerts control, a region of absence that speaks to the power of unseen forces. Light itself behaves unusually near the void's edge. Photons passing through this boundary are subtly redshifted or blue-shifted in ways that challenge standard cosmological models. The cosmic microwave background, which should be largely uniform, shows slight temperature anomalies in the same direction, suggesting that the void's influence extends across vast distances and long periods of time. Observers on Earth detect these effects as faint distortions in the light from distant galaxies, tiny shifts that accumulate over billions of light-years. The result is a region that seems to warp reality itself, bending perception and challenging the human mind's ability to comprehend scale, structure, and cause and effect on cosmic levels. The edge of the void also serves as a natural laboratory for studying extreme physics. Here, the absence of matter and the peculiar behavior of energy provide an unprecedented opportunity to test theories about dark energy, dark matter, and gravitational anomalies. Observations of galaxy motion, light propagation, and cosmic background fluctuations allow scientists to probe conditions that cannot be replicated in laboratories on Earth. Every measurement, every data point, is a clue about the hidden mechanics of the universe. The edge becomes not just a boundary of emptiness, but a bridge between the observable and the speculative, a place where evidence meets imagination. Cinematically, the void's edge is breathtaking. Imagine a cosmic cliff, where the universe drops off into an expanse so vast and empty that human intuition struggles to grasp it. Galaxies hang at the precipice, faint glimmers of light stretching against the backdrop of darkness. The contrast between the dense filaments of the cosmic web and the yawning void is stark, almost shocking in its clarity. Visualizing this boundary evokes a sense of vertigo and awe, as if one could peer into the very heart of nothingness and witness the delicate tension that holds the universe together. It is a scene that conveys scale, mystery, and beauty simultaneously, compelling both the mind and the imagination. The philosophical implications of the edge of reality are equally profound. Humanity often conceives of reality as continuous, predictable, and governed by observable laws. Yet the supervoid and its boundary challenge these assumptions. The universe is not entirely uniform. It contains regions where rules bend, matter disappears, and energy behaves unpredictably. Standing at this edge, metaphorically or observationally, forces a confrontation with the limits of knowledge. It is a reminder that the universe is not entirely knowable, that emptiness can hold power, and that the boundaries of comprehension may be as vast and mysterious as the void itself. The edge also raises questions about causality and cosmic history. How did such a void form? Why is it so empty? Are the anomalies at its edge the result of forces acting within our universe? Or could they reflect interactions with something beyond observable space, perhaps a neighboring universe or an exotic cosmic event? Each question leads to another, a cascade of uncertainty that mirrors the vastness of the void itself. Studying the edge becomes a process of piecing together a story from fragments. The motion of galaxies, the bending of light, the subtle temperature shifts in the cosmic microwave background. Each clue hints at a narrative written in the language of the universe, one that humanity is only beginning to decipher. In essence, the edge of reality represents a threshold between understanding and the unknown. It is a region where the familiar rules of physics coexist with extraordinary anomalies, where light and matter interact in ways that stretch imagination, and where emptiness itself exerts influence. For scientists, it is a frontier for exploration, observation, and theory. For the rest of us, it is a profound metaphor, a place where the universe's grandeur and mystery become tangible, where absence gains presence, and where the boundaries of reality are laid bare. Standing at the edge of the supervoid, one cannot help but feel both awe and fear, a reminder that in the cosmos as in life, the frontier of knowledge is always bordered by the unknown. The supervoid is not merely an anomaly to be observed. It is a laboratory, a natural experiment in the physics of extreme emptiness. Scientists have long studied voids in the cosmic web, understanding them as underdense regions that form naturally when gravity pulls matter into filaments and clusters. Yet this supervoid is unlike any other, a region hundreds of millions of light-years across where baryonic matter, dark matter, and even subtle gravitational effects appear to be profoundly reduced. Its extreme emptiness challenges fundamental assumptions about the universe, raising questions about the nature of matter, energy, and the very structure of spacetime. Studying it requires a blend of observational precision, theoretical innovation, and imaginative speculation, a combination that pushes the boundaries of human knowledge. The first step in understanding cosmic emptiness is measuring it. Astronomers use galaxy surveys, mapping millions of galaxies across vast stretches of sky, to identify regions where matter is unusually sparse. In smaller voids, this method reveals large areas with fewer galaxies than average, yet always with some residual matter and faint filaments of dark matter. The supervoid, however, stands out dramatically. Surveys using instruments like the Sloan Digital Sky Survey and Planck satellite confirm that the void is exceptionally empty, with far fewer galaxies and an underdensity that exceeds what models predict. Even diffuse gas and intergalactic plasma, normally present in voids, appear largely absent. These measurements are painstaking, requiring crosschecks across multiple wavelengths and instruments, yet they converge on the same unsettling conclusion. This void is extreme, almost unnatural, a laboratory of emptiness at a scale humans rarely encounter. Understanding the physics behind such emptiness involves delving into dark matter and dark energy, two components that dominate the universe's mass-energy budget. Dark matter, though invisible, provides the gravitational scaffolding for galaxies and clusters. In conventional voids, dark matter is present but at lower density, subtly influencing the motion of nearby structures. In the supervoid, however, gravitational lensing studies reveal that dark matter is almost entirely absent, suggesting that the region lacks the invisible framework upon which galaxies normally build. Dark energy, which drives the universe's accelerated expansion, may also play a role. Some researchers hypothesize that pockets of intensified or anomalous dark energy could contribute to the extreme emptiness, subtly pushing matter away or thinning the cosmic fabric. These dynamics make the supervoid not merely a gap in the universe, but an arena where fundamental forces interact in ways that remain poorly understood. Observations of light passing through the void provide additional clues. Photons traveling from distant galaxies and the cosmic microwave background experience subtle shifts due to underdense regions, a phenomenon known as the integrated Sachs-Wolf effect. In normal voids, this effect produces minor changes in photon energy, detectable as slight temperature variations in the CMB. In the supervoid, the effect is amplified, suggesting that the void's influence on light and energy is more significant than previously imagined. These measurements allow scientists to map the gravitational potential of the void, offering insights into the distribution of both visible and invisible matter, or the striking lack thereof. The process requires extraordinary precision, as the effects are faint yet persistent across billions of light-years, reinforcing the notion that the void is a dynamic presence, not a passive absence. Simulations are equally critical for understanding the physics of extreme emptiness. Advanced computational models recreate the evolution of the universe from its earliest moments, incorporating baryonic matter, and dark energy to predict the formation of voids. When these simulations attempt to reproduce a void of the supervoid size and density, they fail, producing either smaller regions of underdensity or structures that do not match observations. This discrepancy highlights the challenge posed by the void. Current cosmological models, though highly successful on average, cannot account for the extremes presented by this anomaly. It suggests that there may be additional factors at play: exotic physics, unusual energy distributions, or interactions beyond the observable universe, that contribute to the formation of such a colossal emptiness. The supervoid also provides a unique perspective on the universe's large-scale structure. Most of space is filled with a cosmic web of filaments, clusters, and voids, a pattern that has remained remarkably consistent since the early universe. Yet the supervoid disrupts this pattern dramatically, creating a region of discontinuity, a gap where the cosmic web seems to pause. This discontinuity challenges the assumption that the universe is homogeneous and isotropic on large scales, principles that underpin modern cosmology. By studying the void, scientists can refine their understanding of these assumptions, exploring whether the universe is truly uniform or whether rare, extreme anomalies exist that push the boundaries of theory. Philosophically, the study of cosmic emptiness forces a reconsideration of what nothing truly means. A void is not merely the absence of galaxies. It is a region with complex gravitational, energetic, and structural properties. The supervoid demonstrates that emptiness is active, shaping the motion of surrounding galaxies, influencing light, and potentially interacting with fundamental forces in subtle but measurable ways. It is a reminder that the universe is not simply a collection of visible objects but a dynamic system where even absence carries information, power, and influence. This perspective transforms our conception of space from a passive backdrop to a participant in cosmic evolution. The cinematic imagery of the supervoid underscores its scientific and philosophical significance. Picture a vast expanse stretching hundreds of millions of light-years, empty yet alive with subtle forces, where galaxies cling tenuously to the edges, light bends in delicate arcs, and the cosmic microwave background carries faint echoes of ancient dynamics. It is a stage of extremes, a natural laboratory, and a visual testament to the universe's capacity for both order and anomaly. Observing and understanding this emptiness evokes awe, fear, and curiosity in equal measure, highlighting humanity's drive to explore, comprehend, and confront the unknown. Ultimately, the science of cosmic emptiness is a story of contrasts: the observed versus the predicted, matter versus absence, light versus darkness, order versus anomaly. The supervoid exemplifies this duality, offering an extraordinary opportunity to test the limits of theory, refine observational techniques, and expand philosophical understanding. By studying it, scientists probe the foundations of the universe, exploring how emptiness itself can influence structure, energy, and evolution. It is a reminder that in the cosmos, absence is never passive, and that even the most extreme voids can speak volumes about the nature of reality, inviting humans to listen closely to the subtle, awe-inspiring whispers of the universe. The vast emptiness of the supervoid is not merely a blank canvas. It is a space that has inspired some of the most provocative and unsettling theories in modern cosmology. While observational evidence confirms that the void is extraordinarily empty, the very idea of inside, a region devoid of matter challenges conventional thinking. What could occupy, or more accurately what could influence, a place where galaxies, gas, and even dark matter are scarce or absent? Scientists and theorists have proposed a range of possibilities, some grounded in known physics, others stretching toward the speculative edge of human imagination. Each hypothesis attempts to reconcile the supervoid's extreme characteristics with the broader structure and dynamics of the universe, and each raises profound questions about the limits of reality. One prominent theory involves concentrated fields of dark energy. Dark energy, responsible for the universe's accelerated expansion, is usually treated as uniform, a smooth background force gently pushing galaxies apart. Yet within the supervoid, some cosmologists speculate that dark energy could be locally intensified or behave anomalously. Such a concentration could effectively repel matter, creating a vast emptiness far beyond what normal cosmic evolution would produce. If true, this would mean the supervoid is not simply empty, but a region dominated by an invisible, dynamic force capable of shaping the surrounding cosmic web. The implications are staggering. A single void could subtly influence galactic motion, distort the trajectories of light, and perhaps even hint at new properties of dark energy that have not yet been observed elsewhere. Another hypothesis considers the presence of hidden or exotic matter. Unlike ordinary dark matter, which forms the gravitational backbone for galaxies and clusters, this exotic matter could interact weakly, or not at all, with known forces except gravity. Such matter might occupy the void invisibly, leaving no light or detectable signal, yet subtly influencing the motion of nearby galaxies. Some theorists even suggest that it could be a remnant from early cosmic events, relics of phase transitions in the infant universe, or the leftovers of interactions with structures outside our observable cosmos. In this framework, the void is not empty at all, but a repository for forms of matter that humans cannot detect directly, a hidden ecosystem of physics operating on scales far beyond ordinary perception. Speculation extends into the domain of multiverse theories. If our universe is but one bubble in an infinite sea of universes, the supervoid might mark a point of contact, or near contact, with another universe. The theory suggests that during cosmic inflation, regions of spacetime could have collided, creating scars in the structure of our universe. These scars would manifest as extreme voids, where the density of matter is anomalously low and gravitational forces are subtly altered. The alignment of the supervoid with anomalies in the cosmic microwave background, such as the cold spot, lends some weight to this extraordinary possibility. In this view, the void is not a passive absence but a witness to events that transcend our own universe, a record of encounters with realms that exist beyond observable reality. Quantum effects also enter the conversation. On the smallest scales, the universe is a seething, probabilistic system governed by quantum mechanics. Some researchers propose that the supervoid could be a macroscopic manifestation of quantum fluctuations, regions where the density of matter was unusually low from the earliest moments of cosmic evolution. These fluctuations would have been amplified over billions of years, resulting in a void of unprecedented scale. Such an explanation, while rooted in known physics, highlights the delicate interplay between the microscopic and the cosmic, showing that even the emptiest regions of space may carry the imprint of the universe's earliest quantum events. In this sense, The supervoid is both a laboratory for understanding extreme cosmology and a window into the profound unity of physical law across scales. There are also more radical ideas, bordering on the speculative or philosophical. Some suggest that the void might harbor phenomena that are entirely beyond current scientific detection. Hidden dimensions, unusual topologies of spacetime, or even the seeds of entirely new universes. Others have hypothesized that the void could contain energy states or fields that interact with our universe intermittently, creating subtle effects detectable only through anomalies in galaxy motion, gravitational lensing, or the cosmic microwave background. While these ideas cannot currently be tested with existing technology, they demonstrate the void's capacity to expand human imagination, forcing consideration of realities that may exist beyond ordinary perception. Despite the diversity of theories, a common theme emerges. The supervoid is not simply nothing. It is a dynamic region, potentially influenced by forces, energies, or structures that are hidden, exotic, or otherwise unconventional. Its emptiness is a paradox, both an absence of matter and a locus of influence, a region where physical laws are pushed to extremes, and where subtle effects propagate across billions of light-years. Observations of ghost galaxies at the edges, distortions in light, and anomalies in the cosmic microwave background all suggest that the void is active in its emptiness, shaping and interacting with the surrounding universe in ways that remain mysterious. Cinematically, the void's interior is almost unimaginable. One can picture a dark, silent expanse stretching across hundreds of millions of light-years, where the fabric of space is subtly warped, energy flows invisibly, and light itself bends as it traverses the emptiness. There is no fire, no turbulence, only a vast, serene and unsettling nothingness that nonetheless exerts profound influence. The edges of the void, with ghostly galaxies clinging to its borders, serve as visual reminders that even in absence, the universe communicates, leaving subtle fingerprints of its presence and forces. It is both beautiful and terrifying, a place where imagination and physics converge in an almost cinematic tableau of cosmic mystery. Ultimately, the supervoid challenges humanity to reconsider the meaning of inside and nothing. It is a reminder that emptiness can be active, presence can be hidden, and the universe may contain realities far beyond current understanding. Whether dominated by dark energy, exotic matter, quantum fluctuations, or even multiversal scars, the void is a space where physics, philosophy, and imagination intersect. It is a natural laboratory, a cosmic puzzle, and a profound testament to the universe's capacity for extremes. By exploring the theories about what lies inside, scientists and thinkers alike confront the edges of knowledge, where questions are as important as answers and where the mysteries of emptiness illuminate the deepest truths about the cosmos. The supervoid, in this sense, becomes more than a feature of the universe. It is a narrative in itself, a story of absence that shapes reality, of invisible forces that influence the visible, and of mysteries that compel human curiosity. Each theory about what is inside offers a lens through which to view the universe's grand design and its enigmatic exceptions. In contemplating the void, we confront the limits of observation, the possibilities of undiscovered physics, and the awe-inspiring scale of the cosmos. It is a reminder that even in the most extreme emptiness, there is room for wonder, for speculation, and for the profound thrill of exploring the unknown. The idea of a black hole existing within the supervoid is both compelling and terrifying. At first glance, the concept seems almost contradictory. Black holes are regions of extreme density, points where matter collapses to a singularity and gravity becomes so intense that even light cannot escape. The supervoid, by contrast, is defined by its near-total absence of matter, a yawning expanse hundreds of millions of light-years across, almost completely empty of galaxies, gas, and dark matter. Yet some scientists speculate that the void's extreme characteristics could be explained, at least in part, by the presence of an enormous, hidden black hole, or perhaps something even stranger, a type of ultramassive structure that challenges conventional physics. The idea forces a rethinking of the very definitions of density, mass, and emptiness on cosmic scales. If a black hole, or a series of black holes, resides within the supervoid, it could help explain several of the observed anomalies. For example, the unusual motion of ghost galaxies at the void's edges might be influenced by gravitational forces from a central mass that is otherwise invisible. Light passing near the void experiences subtle distortions, such as gravitational lensing effects, that could indicate the presence of a massive object exerting pull across vast distances. Even the cold spot in the cosmic microwave background could, in theory, be partially influenced by such an object, if it subtly warps spacetime in a way that cools passing photons. While these ideas remain speculative, they offer a framework for connecting disparate observations into a coherent, if unsettling, explanation. One of the challenges in considering a black hole inside the void is scale. The largest known black holes, supermassive black holes at the centers of galaxies, contain billions of solar masses but are minuscule compared to the size of the supervoid. To influence the void on the observed scale, a hypothetical black hole, or collection of black holes, would need to be extraordinarily massive, far beyond anything currently documented. Some theorists have proposed that these could be ultramassive or hypermassive black holes, potentially formed in the early universe under conditions far more extreme than those that produce ordinary supermassive black holes. If such objects exist, they would challenge our understanding of gravitational physics, formation mechanisms, and the upper limits of mass accumulation in the cosmos. Another consideration is the possibility that the supervoid could host an exotic or atypical type of black hole, one that does not behave according to conventional expectations. Theoretical models suggest that primordial black holes, formed from density fluctuations in the early universe, could be scattered throughout space, some reaching immense sizes. Unlike black holes in galactic centers, these primordial black holes could exist in near isolation, undetectable except through their gravitational effects. If one or more of these objects occupy the supervoid, they could create a gravitational landscape that shapes the motion of peripheral galaxies and subtly influences the distribution of energy and light across the void's boundaries. Such a scenario would blend observational evidence with deep theoretical speculation, offering a tantalizing solution to the void's mysteries. The interior of the supervoid, if it contains a black hole, is an environment unlike any other. Imagine a region where matter is nearly absent, yet an invisible mass warps spacetime across millions of light-years. Gravitational fields could subtly bend the trajectories of light, influence the motion of nearby clusters, and leave detectable imprints in the cosmic microwave background. The black hole's presence would not manifest as a visible object but as a profound absence, a force without form, shaping the cosmos through its gravitational pull. Observationally, scientists would detect only indirect evidence. Slight anomalies in galaxy motion, deviations in expected lensing patterns, and minute fluctuations in the oldest light in the universe. This hidden influence makes the supervoid both eerie and scientifically rich, a laboratory for probing gravity under extreme and unusual conditions. Cinematic visualization of this concept is striking. Picture the supervoid as a vast, dark expanse, empty to all appearances, yet containing at its center a singularity so massive it subtly warps the surrounding space. Galaxies at the periphery trace elongated, distorted paths, light bends in invisible arcs, and the cosmic microwave background registers faint, cold imprints. The void becomes a stage where absence and presence coexist, where a hidden force exerts its influence silently, and where the rules of perception and expectation are challenged. It is a scene of tension and mystery, evoking awe, fear, and profound curiosity about the universe's hidden mechanisms. Philosophically, the concept raises deep questions about perception and understanding. The supervoid, already an extreme example of emptiness, could conceal a mass so immense that it shapes reality invisibly. This challenges the notion that the absence of visible matter equates to nothingness. It demonstrates that the universe can harbor extremes of both density and emptiness in the same region, and that phenomena beyond direct observation may govern the behavior of the cosmos on the largest scales. The void, therefore, is not a passive absence but an active participant in cosmic evolution, and contemplating a black hole inside it forces a re-evaluation of what it means for a region of space to exist, in terms of influence rather than substance. Testing these ideas remains a monumental challenge. Direct observation of such a black hole is likely impossible with current technology, given its isolation and the lack of nearby matter to illuminate it. Instead, researchers rely on indirect measurements, tracking the motion of peripheral galaxies, analyzing subtle gravitational lensing effects, and studying patterns in the cosmic microwave background. Advanced simulations model hypothetical black holes within vast voids to predict their influence on surrounding space and to compare with observational data. Each anomaly becomes a clue, a potential indicator of a hidden mass shaping reality from the shadows. Ultimately, the question of whether a black hole exists inside the supervoid blends science, theory, and imagination. It highlights the universe's capacity for extremes, where vast emptiness and intense gravity may coexist, and where phenomena beyond direct detection can leave observable traces across billions of light-years. The supervoid, as a region of profound mystery, invites humanity to consider forces and structures far beyond ordinary comprehension. Whether it contains a black hole, exotic matter, or unknown forms of energy, the void demonstrates that the cosmos is both stranger and more complex than our intuition allows, and that even absence can carry immense weight, shaping reality in subtle but undeniable ways. The concept of a wormhole, a theoretical tunnel connecting distant regions of space-time, has long captured both the imagination of scientists and the fascination of the public. Wormholes are predicted by solutions to Einstein's equations of general relativity, representing shortcuts through the fabric of spacetime that could, in principle, allow matter or information to travel vast distances instantaneously. While their existence remains purely theoretical, the extreme characteristics of the supervoid have prompted some scientists to speculate whether it could conceal a wormhole, or at least a structure with similar properties. Unlike ordinary voids, which are simply empty regions, the supervoid exerts influence across vast distances, alters the flow of light, and creates gravitational anomalies. Could these effects be the signature of something far more exotic than an absence of matter? To understand the wormhole hypothesis, one must imagine spacetime as a flexible sheet. Normally, the sheet is smooth, stretching uniformly across the cosmos. A void is simply a thinning of the sheet, a lack of material and gravitational influence. A wormhole, by contrast, is a tunnel through the sheet itself, a bridge connecting one region to another, potentially across billions of light-years. In this scenario, the supervoid could be the visible mouth of such a structure, an area where matter is unusually absent not by mere underdensity, but because space itself has been warped to create a shortcut. This possibility, though speculative, aligns with some of the observed anomalies: subtle gravitational lensing, the cold spot in the cosmic microwave background, and distortions in galaxy motion at the void's periphery. The physics of a wormhole is daunting. To remain stable, a traversable wormhole would require exotic matter with negative energy density to prevent collapse. While this remains hypothetical, the supervoid provides an intriguing natural laboratory for considering such possibilities. Its immense scale, hundreds of millions of light-years across, suggests that if a wormhole exists, it could operate on a scale far beyond anything previously imagined. Light and gravitational forces passing through or near the structure would behave unpredictably, producing effects that might be detectable from Earth. The void's extreme emptiness could thus be explained not as a mere absence of matter, but as a region of spacetime that has been distorted by an underlying tunnel connecting distant regions of the cosmos. Observational evidence is subtle but compelling enough to fuel speculation. The alignment of the supervoid with the cold spot in the cosmic microwave background is one piece of the puzzle. Photons passing through a wormhole or a highly warped region of spacetime could lose or gain energy, producing temperature variations detectable across billions of light-years. The extreme underdensity of galaxies within the void might also be a consequence of space being stretched or redirected along a tunnel-like pathway. While alternative explanations exist, dark energy anomalies, gravitational effects from hidden mass, the wormhole hypothesis offers a unified, if highly speculative, framework for interpreting multiple observations simultaneously. It is a hypothesis that sits at the intersection of theory, imagination, and cosmological anomaly. Visualizing a wormhole inside the supervoid is cinematic and unsettling. Imagine a vast expanse of darkness, hundreds of millions of light-years wide, empty of stars and galaxies, yet containing a region where space itself curves inward like the walls of a tunnel. Light bends subtly around the entrance, distant galaxies appear stretched or warped, and the cosmic microwave background registers faint, cold imprints along its path. The void becomes more than a simple emptiness. It becomes a stage for a phenomenon that challenges the very concepts of distance, matter, and time. The cinematic tension is palpable. The void appears serene, yet it may conceal a structure of extraordinary power and complexity, a cosmic gateway beyond human experience. Philosophically, the wormhole hypothesis confronts humanity with profound questions about the nature of reality. If the supervoid is indeed a wormhole, it would imply that the universe is far more interconnected than previously thought, with pathways linking regions separated by billions of light-years. It would challenge assumptions about isolation, scale, and causality, and suggest that spacetime itself is dynamic, flexible, and capable of supporting structures that exceed our current understanding. Even contemplating this possibility stretches the limits of imagination, blending the tangible with the theoretical and highlighting the universe's capacity for both mystery and wonder. Yet the hypothesis also demands caution. Wormholes remain unobserved, and their existence depends on conditions that may be physically impossible or extremely rare. Many scientists approach the idea with skepticism, emphasizing that conventional explanations, such as variations in dark energy, gravitational anomalies, or statistical flukes, are more consistent with known physics. Nevertheless, the supervoid's extremity and the persistent anomalies associated with it mean that the wormhole hypothesis cannot be dismissed outright. It serves as a provocative thought experiment, one that pushes the boundaries of cosmology and encourages consideration of exotic possibilities that challenge the limits of observation, theory, and imagination. From a scientific perspective, testing the wormhole hypothesis is exceptionally difficult. Unlike black holes, which can be inferred from gravitational lensing, radiation, and motion of nearby objects, a wormhole could remain largely invisible, leaving only indirect clues. These clues might include subtle distortions in galaxy trajectories, energy shifts in the cosmic microwave background, or anomalous gravitational lensing effects. Observational astronomers must carefully map the supervoid across multiple wavelengths and compare results with theoretical models of spacetime curvature. Each anomaly becomes a potential signal, a piece of a puzzle that may hint at an underlying structure far more exotic than ordinary voids or massive objects. Ultimately, the idea that the supervoid could be a wormhole embodies the tension between the known and the unknown, presence and absence, reality and speculation. It is a concept that blends the rigor of physics with the expansiveness of imagination, forcing consideration of forces, structures, and connections that operate on scales beyond ordinary comprehension. Whether or not the supervoid conceals a wormhole, the hypothesis itself underscores the richness of cosmic mystery. A vast, empty region may harbor possibilities that redefine our understanding of space, time, and the universe's hidden architecture. In contemplating a wormhole within the supervoid, humanity is confronted with the tantalizing potential of discovery, the thrill of the unknown, and the profound realization that even the emptiest regions of the cosmos may conceal extraordinary secrets. The discovery of the supervoid and the possibilities it holds stretches far beyond scientific curiosity. It challenges the very way humanity understands its place in the cosmos. For centuries, humans have looked at the night sky and seen order, stars clustered in galaxies, galaxies forming structures, and patterns that suggested a predictable, understandable universe. The supervoid shatters that comforting assumption. It is a region of unimaginable emptiness, yet it influences galaxies, light, and cosmic background radiation across billions of light-years. The realization that such vast active nothingness exists forces a confrontation with the limitations of human perception, the incompleteness of our models, and the fragile certainty of what we call reality. On a philosophical level, the void raises profound existential questions. Humanity often conceives of space as a backdrop, a stage on which the drama of stars, planets, and life unfolds. The supervoid challenges this notion, suggesting that emptiness itself is active, capable of shaping events, influencing structure, and perhaps holding secrets beyond our current understanding. If the void contains dark energy anomalies, hidden matter, black holes, or even a wormhole, then humans are observers on the edge of phenomena that dwarf our comprehension. It forces the question, how much of the universe operates beyond our detection, silently influencing the cosmos while remaining imperceptible to human senses? This awareness can be both humbling and unsettling, a reminder of how small and provisional our knowledge truly is. The implications extend to the philosophical debate about our cosmic significance. The supervoid is not merely a distant curiosity. It embodies the idea that the universe is vast, unpredictable, and potentially filled with forces entirely outside human control or observation. In confronting such a region, humanity must recognize its limited perspective. Our knowledge of the cosmos is derived from light that has traveled billions of years, filtered through instruments, interpreted by models, and always incomplete. The supervoid represents the extremes of this incompleteness, a region where absence dominates, yet where invisible forces may shape reality in ways we have yet to imagine. It is a humbling reminder that the universe is not designed to accommodate human understanding. It exists on scales, in forces, and in mysteries that transcend our everyday experience. From a scientific perspective, the implications are equally profound. Understanding the supervoid could reshape physics, cosmology, and even technology. If it contains concentrated dark energy, it could reveal new properties of one of the universe's most mysterious forces. If it harbors hidden matter, ultramassive black holes, or exotic structures, it could expand the known limits of gravitational physics, energy dynamics, and the behavior of matter under extreme conditions. Even the speculative possibility of a wormhole within the void challenges the fundamental understanding of spacetime, suggesting that shortcuts through the cosmos may exist, however theoretical. Each of these revelations has the potential to rewrite textbooks, redefine what is physically possible, and inspire generations of scientists to explore the edges of the unknown. Culturally, the discovery of the supervoid resonates deeply with human imagination. Stories of vast emptiness, cosmic tunnels, and unseen forces have long captivated writers, philosophers, and artists. The void becomes a mirror for human curiosity, a symbol of both the limits and the possibilities of exploration. It challenges narratives of control and understanding, emphasizing instead the awe-inspiring vastness and unpredictability of the universe. In confronting the void, humanity is reminded of the power of wonder and imagination, of the necessity to question assumptions, and of the thrill inherent in seeking knowledge where answers are scarce, incomplete, or entirely absent. The supervoid also invites reflection on technological and observational progress. Mapping and studying such a region requires the most advanced telescopes, satellite instruments, and computational simulations. Humanity's ability to detect anomalies across hundreds of millions of light-years demonstrates both the ingenuity and the persistence of scientific endeavor. Yet even with these tools, the void remains largely inscrutable, highlighting the limitations of current technology and the challenges of observing phenomena that exist at the edge of perception. This duality, capability and limitation, underscores the ongoing human journey, to probe the cosmos, to seek understanding, and to grapple with mysteries that may never be fully resolved. The psychological impact of contemplating the void should not be underestimated. Humans instinctively fear absence, emptiness, and the unknown. The supervoid embodies all three, on a scale that is almost incomprehensible. Standing metaphorically at the edge of this vast emptiness evokes a mixture of awe, terror, and curiosity. It is a confrontation with the sublime, a moment where human cognition struggles to process magnitude, scale, and influence. This encounter challenges not only our understanding of the cosmos but also our emotional and philosophical responses to the infinite, reinforcing the unique interplay between knowledge, perception, and the imagination. There are also practical considerations for humanity's understanding of cosmic risk. While the supervoid poses no immediate threat, its extreme nature forces us to consider how large-scale, unpredictable phenomena can influence the universe. Could regions of extreme emptiness impact cosmic expansion, the motion of galaxies, or the propagation of light and energy in ways we cannot yet predict? Understanding these dynamics is not just a theoretical exercise. It refines our models of the universe and improves our ability to predict cosmic evolution on vast scales. The supervoid thus represents both a challenge and an opportunity, a chance to expand knowledge while confronting the reality that the cosmos is governed by forces far beyond ordinary comprehension. Ultimately, the supervoid reshapes humanity's perspective on existence, knowledge, and ambition. It embodies the tension between the known and the unknown, the visible and the invisible, presence and absence. It reminds us that even in regions of emptiness, forces are at work that shape reality, influence structure, and challenge understanding. The void is a profound symbol of cosmic humility. The universe is vast, intricate, and often beyond human control, yet it is accessible through observation, imagination, and relentless curiosity. By studying and contemplating such regions, humanity not only advances science but also deepens its appreciation for the mysteries of existence, the power of discovery, and the infinite possibilities that lie beyond the familiar stars in the night sky. The discovery of the supervoid has ushered in a new era of cosmic exploration, one defined not by what is present in the universe but by the astonishing phenomena that arise from absence itself. For decades, humanity has charted the cosmos by studying stars, galaxies, nebulae, and the complex structures of the cosmic web. But the supervoid forces a shift in perspective. Empty regions are no longer ignored as mere gaps between matter. They are recognized as arenas of profound scientific interest, laboratories for understanding the universe's most extreme conditions. The future of exploration is thus moving toward mapping, monitoring, and decoding these regions of emptiness, leveraging technology, theory, and imagination to probe the universe in entirely new ways. Next-generation telescopes and space observatories will play a pivotal role in this endeavor. Instruments with unprecedented sensitivity across multiple wavelengths, from radio to infrared, X-ray, and gamma-ray, will allow scientists to detect subtle gravitational effects, faint background radiation, and the elusive signals of dark matter and dark energy. Projects like the James Webb Space Telescope, the Vera Rubin Observatory, and future space-based interferometers are designed to capture data at scales and resolutions never before achieved. These technologies will enable astronomers to construct detailed maps of the supervoid, examining its structure, boundaries, and potential internal anomalies with precision. The void, once a silent emptiness, will become a rich source of observational data, offering insight into the forces that shape the universe. Computational modeling and artificial intelligence will also revolutionize our understanding of the supervoid. Advanced simulations of cosmic evolution, incorporating dark energy, dark matter, and gravitational interactions, can test hypotheses about how such extreme voids form and evolve. AI-driven analysis can identify patterns in vast datasets, detect anomalies invisible to human observers, and even predict where similar voids might exist elsewhere in the universe. This synergy between observational technology and computational modeling represents a powerful new paradigm, exploring the cosmos not only by looking but also by analyzing and simulating, blending theory and evidence to uncover hidden truths. The supervoid is thus both a challenge and an opportunity, pushing humanity to innovate in how we study the universe. The potential for revolutionary discoveries extends beyond pure science. If the supervoid contains exotic phenomena, such as ultramassive black holes, hidden dark matter structures, or even a wormhole, it could redefine our understanding of physics and the cosmos. Discovering a wormhole, for example, would have profound implications for spacetime travel and fundamental laws of nature. Even the confirmation of extreme dark energy anomalies would expand the boundaries of theoretical physics, offering new insights into the universe's expansion and ultimate fate. In this sense, the future of cosmic exploration is inseparable from the frontiers of knowledge. Investigating the supervoid is not merely an academic exercise, but a quest to understand forces and structures that may govern the universe on the largest scales. Cinematically, the exploration of the supervoid offers a vision of the future that is both awe-inspiring and deeply mysterious. Imagine spacecraft and observatories peering into a vast, dark expanse, mapping invisible gravitational fields, charting the motion of ghostly galaxies, and detecting subtle distortions in light that reveal hidden forces. Human ingenuity extends across hundreds of millions of light-years, attempting to illuminate regions that appear devoid of matter yet teem with physical significance. Each observation is a step into the unknown, a confrontation with extremes of scale, energy, and absence that challenge the human imagination. The supervoid becomes a stage for cosmic discovery, a place where science and wonder converge. The future of exploration is not limited to observation from Earth or its orbit. Concepts for deep space probes, capable of traveling to the edges of observable voids, are being theorized. While the supervoid itself is far beyond the reach of current spacecraft, technological advances in propulsion, energy storage, and autonomous navigation could one day make it possible to study these regions more directly. These missions would encounter unprecedented conditions: vast stretches of emptiness, minimal gravitational pull, and extreme isolation from the luminous matter that usually guides navigation. Yet the scientific rewards, direct measurements of cosmic emptiness, detection of subtle forces, and potential encounters with exotic structures, would be unparalleled, offering insights into the fundamental architecture of reality itself. Collaboration across disciplines will also define the future of cosmic exploration. Cosmologists, physicists, mathematicians, and engineers must work together, combining observational expertise, theoretical frameworks, and technological innovation to tackle the challenges posed by the supervoid. Philosophers, artists, and communicators also play a role, helping translate the implications of discovery into narratives that inspire, educate, and expand human perspective. Exploration in this sense is not just about collecting data, it is about integrating knowledge, fostering creativity, and cultivating a sense of shared wonder at the universe's vastness and complexity. The supervoid becomes a catalyst for interdisciplinary advancement, pushing humanity to think, imagine, and innovate on unprecedented scales. Moreover, the study of supervoids may redefine humanity's long-term vision for the cosmos. Regions of extreme emptiness highlight the dynamic and interconnected nature of the universe, emphasizing that even absence carries influence and meaning. Understanding these regions may inform predictions about cosmic evolution, the behavior of dark energy, and the ultimate fate of the universe. It may also inspire new philosophical and existential perspectives, reshaping humanity's conception of its place in the cosmos. The supervoid, once a distant anomaly, thus becomes central to the ongoing story of exploration, knowledge, and understanding, inviting humans to confront questions about existence, scale, and the limits of comprehension. Ultimately, the future of cosmic exploration is defined by curiosity, perseverance, and the courage to confront the unknown. The supervoid exemplifies the frontiers of this journey, It is a region of emptiness that paradoxically brims with significance, a challenge that demands both technological prowess and imaginative insight. By studying it, humanity stretches the limits of observation, theory, and understanding, seeking to illuminate not just what is present in the universe but what is hidden, subtle, or extreme. Exploration in the coming decades will increasingly focus on these enigmatic regions, mapping, analyzing, and interpreting them in ways that may redefine our knowledge of the cosmos. In embracing the challenge of the supervoid, humanity stands at the threshold of a new era, where the study of emptiness itself becomes a gateway to discovery, insight, and awe. Standing before the vastness of the supervoid is an exercise in humility, a confrontation with the enormity of the universe that reshapes perspective in ways both profound and unsettling. From Earth, humans look up at the stars and imagine the night sky as a map of order and certainty. Constellations, galaxies, and nebulae provide points of reference, a comforting framework for orientation and understanding. Yet the supervoid disrupts that framework entirely. It is a region hundreds of millions of light-years across where matter, light, and even the scaffolding of dark matter are sparse or absent. The familiar signs of cosmic structure vanish, replaced by a silent emptiness whose very presence challenges our assumptions about scale, density, and the nature of reality. Observing it forces a step back, a shift from the small and immediate to the vast, extreme, and almost incomprehensible. The cosmic perspective offered by the supervoid is more than just an intellectual exercise. It is an emotional and philosophical journey. Confronting such emptiness evokes awe, fear, and wonder simultaneously. There is a paradox in feeling the universe's magnitude so intensely while recognizing one's own minuteness in comparison. Human history is full of attempts to grasp scale, from the earliest myths to the latest scientific models, yet nothing quite prepares one for the experience of contemplating a void so immense and profound. It is an emptiness that carries weight, a silent influence that shapes the universe despite, or because of, its lack of visible matter. The mind struggles to accommodate such scale, highlighting both the limitations and the potential of human cognition. From a scientific viewpoint, the supervoid illustrates the interconnectedness of cosmic phenomena. Light from distant galaxies bends and shifts subtly as it passes through or near the void, gravitational effects ripple outward from its edges, and temperature variations in the cosmic microwave background reveal faint imprints of its presence. These signals demonstrate that even regions defined by absence are active participants in the universe's dynamics. By studying the void, scientists gain insights into fundamental forces, gravity, dark energy, and possibly unknown interactions that operate across unimaginable distances. It underscores a central principle of cosmology: emptiness is never truly empty. The supervoid, in its silence, communicates the laws of physics on the grandest scales, offering lessons about energy, matter, and the very structure of spacetime. The cosmic perspective also reshapes humanity's understanding of time and existence. The light that reaches us from the supervoid has traveled for billions of years, a journey that spans epochs far beyond human history. Observing this region is akin to peering back into the universe's past, witnessing conditions that existed when galaxies, stars, and even our solar system were far younger. It is a temporal as well as spatial perspective, connecting human perception to the deep history of the cosmos. The supervoid becomes a bridge between the present and the distant past, a reminder that all observation is also an act of memory, tracing the evolution of space and time across incomprehensible scales. Philosophically, the supervoid invites reflection on the nature of reality and perception. Humans are accustomed to defining existence in terms of presence, objects, matter, and observable phenomena. The void challenges this instinct, suggesting that absence can be as influential as presence, shaping motion, light, and cosmic structure in ways that are both subtle and profound. It forces reconsideration of what it means for something to exist, and what constitutes meaningful influence. The universe, as revealed by the supervoid, is not solely composed of what we can see or detect. It includes invisible forces, subtle dynamics, and regions where emptiness itself has agency. Engaging with this reality expands the mind, blending physics with philosophy and observation with imagination. Cinematically, the supervoid offers one of the most striking visualizations of the cosmos. Picture a vast expanse stretching across hundreds of millions of light-years, dark and nearly empty, yet alive with subtle distortions, ghostly galaxies on the periphery, and faint warps in the light that hint at invisible forces. The contrast between the dense cosmic web surrounding the void and the yawning emptiness within creates a dramatic tableau of presence and absence. It is a stage where the scale of the universe is made tangible, where the tension between what exists and what is absent evokes both beauty and unease. This visualization reinforces the emotional and intellectual impact of the cosmic perspective, making the abstract principles of astrophysics profoundly visceral. The cosmic perspective also fosters humility and curiosity. Recognizing the supervoid scale and significance highlights humanity's smallness in the grand scheme of the universe, yet it also emphasizes our capacity for understanding, observation, and imagination. The ability to detect subtle effects, map immense regions of emptiness, and theorize about phenomena as extreme as black holes, exotic matter, or wormholes is a testament to human ingenuity. In contemplating the supervoid, humans confront their limitations while simultaneously celebrating their achievements, experiencing the duality of insignificance and empowerment. It is a perspective that encourages both awe and aspiration, urging continued exploration and discovery. Finally, the supervoid exemplifies the ultimate lesson of the cosmic perspective, that the universe is far more complex, dynamic, and mysterious than our everyday experiences suggest. It reminds us that knowledge is provisional, perception is limited, and reality encompasses scales, forces, and phenomena that challenge comprehension. Yet it also offers hope, curiosity, and inspiration, demonstrating that through observation, theory, and imagination, humanity can engage meaningfully with even the most extreme and enigmatic regions of existence. The supervoid becomes a symbol of both the unknown and the knowable, a mirror for our place in the cosmos, and a reminder that even in the emptiest stretches of space, there is profound meaning, subtle influence, and an inexhaustible call to explore.